Yo minasan. Let's start our lecture 8 summary. So, in this lecture, we'll see combination of batteries. So, in combination, first we'll see serial arrangement or combination of batteries. So, in this, it is much simpler. So, if we combine batteries with their own internal resistance, we'll just add them up. So, if this is E1, this is R1, E2, R2, E3, R3, then the uh, net would be E equivalent would be E1 plus E2 plus E3 and so on, and net resistance would be R1 plus R2 plus R3 and so on. And that's it, I guess. Now, for some examples, so this is 2 volts, this is 4 volts, this is 6 volts, this is 2 ohms, this is 2 ohms and 2 ohms. Yep, 2 ohms and 2 ohms. So the net voltage would be 6 and 6, 12 volts. Net resistance would be 6. So I would be V by R, so 2 amperes. Now, what if we flip one of these? Then, instead of being pushed like this, some of it will be pushed like that. So, net uh, net voltage would be 6 plus 2 minus 4. That would be 4 volts. So, this would be 4 by 6, 2 by 3 ampere. Now, what if twin cells are joined in series? That would just mean if m such uh, batteries are joined, then equivalent would be ME, and resistance equivalent would be MR. Now, uh, we can just, what if all of this we can, if we add all this, and what if we want to find, if it is joined with another external resistor of resistance R, then it would mean E equals to E equivalent by R equivalent plus R, which is MR plus R. So if MR greater than R, that would mean it would simply be E by R, M and M gets cancelled. And if MR is greater than MR, then I would just be ME by R. So in this case, uh, no matter how many such you can increase, we'll get, uh, if we increase any number of resistors, the current would be constant here. But here, if we can control the current by just varying the external resistance. So then now we'll look at torch. Now this principle also works for batteries in remotes and all. So there we have to uh, insert them in certain way to allow them to be in series so that we get maximum out. Yeah. Now, next stop would be parallel resistors, parallel combo. In this, after all the derivation, we just have, if this is E1 with resistance R1, E2 by with R2, E3 with R3. The net equivalent resistance of this would be E equivalent equals to E1 by R1 plus E1 by R2, E2 by R2 plus E3 by R3 by 1 by R1 plus 1 by R2 plus 1 by R3. And if any external resistors are joined, we will find about that later. While finding out about current, we can use that. So if another R resistor is here, then I would be E equivalent by uh, the net resistance R equivalent plus R. Yeah. So let's see question on this. So here this is 10 volts, this is 20 volts, this is 2 ohms, 2 ohms, 3 ohms. So E equivalent would be 1 by not 1, 10 by 2 plus 20 by 2 by 1 by 2 plus 1 by 2. Yeah, so that would be 10 plus 5 plus 10 by 1 equals to 15 volts. Now R equivalent equals to 1 itself. So I equals to 15 by 1 plus 3 equals to 15 by 4 amperes. Now what if this was reversed? Then it would mean minus. So this would be minus 5. So this would be minus 5 by 4. Minus here indicates that it is in the opposite direction. So let's just flip it over here. So this would be more and this would be less. So electrons would be pushed more here, not electrons, charge would be pushed more towards this and this would be minus. Next up, what if there is the battery itself here? Then that would be with its own resistance. E equivalent here, this is 20 here, 22, and this is 30 volts. And this is 10 volts, 2 ohms. So E equivalent would be 10 by 2 is 20 by 2 is 10. This is 15 by 1 by 2 plus 1 by 2 is 1 equals to 25. And this is E equivalent 1 and whole would be 25 plus 10, 25 plus 10 equals to 35 volts. R equivalent, R E1 would be 1 itself. R E cube would be, here it would be minus. because this is in reverse. So this would be 15, and then R equivalent is 1 plus 2 plus 3, that is 6. So I equals to 15 by 6. Yep, that's 15 by 6. What if n identical such are in parallel? So n such identical batteries in parallel. So that would be n such E, this is R, this is E, this is R, this is E, this is R, this is E, this is R. So if we see all this, it would be N E by N E by R by N by R. So N by R, N by R, it cancelled out. So this means all of them would, like, jitna one would exert its voltage, all together will have a common point. So what its potential is, the same potential would be here. Then what if we have grid? So in a grid, there are m such rows in a series. So that would be MR, ME and MR, ME, MR, ME, MR, ME and MR. So here, instead of M and E by R, here M, so M and M cancel. There also E would be same. R equivalent would be different. So M R N by MR, that is N by MR. So R equivalent would be MR by N. So now, if we want to find out, this would be N by R into, just a minute. We apply the same formula here. This would be ME by MR n times. So that would be n times such divided by n times R. So here also they would get cancelled. M such times MR, not just n by R, M would remain. So that would be ME. So this would apply the same as all together. So ME, R equivalent will be N by MR. So M by NR, MR by M. Now you can see we have a formula here for a grid. For I equals to ME by, if we take the other approach here, if we write those resistances like this, MR by M, there's an external another resistor, I equals to ME by R plus MR by M. Now if we MNE by NR plus MR, for to maximize this, we'd want to have this to be small, right? So in that case, for maximum current, we first want this to be small as possible. So NR plus MR, it's derivative should be equal to 0. So n plus m and n are the inputs. So we will have n square by m. So what we are doing basically is that we are taking this, as we need to differentiate over something, we'll just for this it would be if we multiply m and n, uh, multiply and divide m and n, this if we take it as k, and if we differentiate with respect to n, we'd get r into 1 minus k into r divided by n square. Right. Now this is equal to 0. So m into n and n gets cancelled. So n into r equals to m into r. For these values, we'd have current to be greater m into n e by 2nr. So n and n cancel. Or we can have m into n by e by 2mr. M and m get cancelled. This is for IMAX. Okay, that IMAX. That's it for today. Thank you.